In this example, we want to create a properly labeled and scaled graph of time versus speed. So in this case, we have time versus speed. So whenever you have time versus speed, we just need to always remember that what is listed first goes on the y-axis and what is listed second goes on the x-axis. In this case, we are going to plot speed in kilometers per hour on the x-axis and time on the y-axis. So that's the very first thing I'm going to do is I'm going to choose what to plot. And then I'm going to label my axes. So I'm going to label speed in kilometers per hour on the x-axis. And then I'm going to put my time in hours on my y-axis. So that's the first thing that I'm going to do. The next thing I have to do is I have to choose an appropriate axis scale. So there's different ways to do this. But one of the easier ways, just so you have a method every time and you're not having to kind of guess, is that you can actually count the lines. So on the x-axis, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So I have 20 lines. And for the x-axis value, I look at what my highest value is. Now, this table is out of order, so I just have to find the highest one, which is 96. And what I want to do is I'm going to take 96 and I'm going to divide it by 20. And when I do that, I get 4.8. Now, 4.8 would be really weird to make a scale. But what I want to round up to something that would make sense that I could estimate in between the lines. So 4.8 is approximately 5. So then I'm going to start with 0. You don't technically have to start with 0, but people tend to make mistakes when they don't start with 0. So it's best if you go through and start with 0 every time. It won't be wrong if you do that. And then I have to make sure I go by the same number of lines every time. Now, every one of these lines is going to be 5, but if I label every single one of those, it's going to be crowded. So a lot of times what I'll do is I will skip a line. So I know that this first line is a 5, but I'm going to skip it and then I'm going to go 10. And then 15 is skipped and then I'm going to go 20. 25 is skipped, 30, skip 40, skip 50, skip 60, skip 70, skip 80, skip 90, skip 100. My goal was to get to 96. I got to 100. Now, if you can't always get that close, I mean, 96 is going to be in this last row right over here. So if you can't get exactly there, you want to get for sure guaranteed over halfway. And if you can, you need to make sure you get about 75%. As long as one axis is all the way and the other is 75%, you're going to be okay. If they're both halfway, you're going to be way under. So you need to try and get them as big as you can. That's going to be really important for when we start to draw best fit lines later. So that was for my x-axis. Now, when I look at my y-axis, my highest value on the y-axis is actually a 10.43. It was actually in the middle of my data right there because these weren't in order. So I'm going to count my lines. And I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 this time. So I need to get 10.43 divided by 15. And when I do that, I get a number that is equal to 0.695. Now, that is really, really awkward. I don't like that at all. So on this one, I'm actually going to round it up to 1. Some other things I could have done, I could have done like 0.75. 0.75 would get me pretty good on the lines, and then every other line would be 1.5, and then every fourth line would be 3. I could do that, but I'm just going to go straight to 1 because I went all the way to the end on my x-axis, so I can go a little bit short on my y-axis. So I'm going to approximate each of these as a 1. So each line is going to be a 1. So that's a 1 right there, but I'm going to skip it because I don't want to write every single one. Now, if you want to write every single line because it helps you, you can do that. It just gets a little crowded. I will say that if you do get crowded, especially on the x-axis is where that's going to happen, you can tilt your numbers. So sometimes to give you more space between your numbers, you can tilt them. So that is something that you can do to make it easier to read if you add more lines in. So on the y-axis, I'm going to go by every one. So every other one is 2. So that's going to be 2, 4, 6, 8, 10, and 12. I could go up and label all the way, but I don't really have to because my highest number is 10.43. So did I get 75%? Probably. I'm pretty close. Could I have spread it out more if I had gone with 0.75? Yes, but this will be good enough. Because when I look at the numbers, I want to go to about 10.43. This number is 11. So I'm going to about here and then to 96. My data is going to come here. And I would say that is probably about 75% of my page. So that's good. I don't really want to get too much smaller than that. So once I have my axis labels and I have my axis scale, the next thing I need to do is go and actually plot my data. So I need to make sure that I get really as close as I can on these points. And if your scale is awkward and hard to read, sometimes it takes more time to estimate those weird points. So sometimes it's kind of a give or take as to what you want to do, because sometimes it'll take you more time to plot weird numbers, but everybody's a little bit different. So in this case, what I'm going to do is I'm going to start with my first data point. So my x-axis is 60 and my y-axis is 6.12. So if I go to 60, 60 is here, and then I'm going to go up to 6.12. So this line right here would be 60, sorry, right, 60, and that would be 6, but I don't want 6. I want 6.12. Well, that's 7. So 6.1 is going to be much closer to 6 than it is to 7. So I'm going to draw that one like right about there. I'm going to use a nice big bold dot. So if you were to do that one, I made a little dot here, so I would like erase that. I don't want any stray markings when I'm doing this. So my next point is 82 and 4.57. So 80 is here. That line's 85. So 82 is going to be a little less than halfway. So it's going to be something like right there. And I need to go up to 4.57. Well, if I go up, this line right there is 5. So I want to go a little less than 5. Sorry, it doesn't like me to draw on top of this guy. Sure why it's having issues there. But there we go. All right. So that's going to be about 4.57. Might be a little high. That's okay. It's an estimation. So then my next number is 35 and 10.43. So 35 is easy because that's right here on the line. And then 10.43 is going to be a little less than, oh, it's going to be halfway between 10 and 11. 11 is that line. So I go to 10, 11, halfway. So that's 35 and about 10.43. And then my next one is 91 and 3.82. So 91 is just going to be right past 90. And then 3.82, this line right here is 3, but 8.2 is 0.82 is going to be pretty close to 4. So I'm going to do 91 and about, come on, you can do it. Sorry. I don't normally do a lot of plotting on this thing. So it need to be 3, 3.82. There we go. Something like that. Let's see if I can make that. Oh, and then my very last one's kind of close to that. That's 96. So that's just past the midpoint, which is 95. And I'm at 3.72. So I just need to make sure, I might have done that one a little low. So I just need to make sure I'm kind of close, but I need to be at least halfway. Okay, come on, you can do it. Sorry, I'm sure that was a little painful to watch. Those two are probably a little low. If you look at the actual example, those are a little bit higher. So that gives me my graph. Now, if I had used my estimation method for finding my scale, I would have ended up with this exact same graph. And I would have just kind of guessed and checked and kind of just gone through some example numbers that I would have liked, but I would still end up with this same graph. If you end up with a different graph than what's on the answer keys, that doesn't mean you're wrong. What AP graders are going to be looking for is they're going to make looking for that you have at least half of the grid occupied by data. So I give you a rule of 75%. So that way, if you fall a little short, you're okay. But by habit, you want to try and get at least 75% every time, and this would meet that. I have my variable and my unit on each of my axes. I made sure that I go by the same amount on each of my scale and that my data is plotted pretty darn close. So I can't really tell from this graph if it's supposed to be a curve or it's supposed to be linear, but that's going to be kind of our next topic is what do we do once we have our data plotted?